In the last video on inelastic collisions, I talked about how you can use the concept of conservation of momentum to find out what's happening in the after situation, because we know that the total momentum of the system has to equal the total momentum afterwards if we have conservation of momentum. So I knew that the total momentum of the whole system still had to be 10 kilogram meters per second. Okay? And so from that we calculated the final speed. So with inelastic collisions, or all collisions, even elastic, we have a conservation of momentum always. So momentum is conserved. That's always true in an ideal situation. Okay, so what does that mean? Well, it just means that the initial momentum of that system equals the final momentum of the system, and that's what we just set up here. This dashed line up here, the initial equals the final. Fine. But one thing that's not true is conservation of kinetic energy. So kinetic energy is not conserved. And so why is that important? Well, if two objects are coming together, if I found the energy of the system before, it's not going to be the same as the energy after. Okay, so I'll prove it in this situation here. The kinetic energy initial in this case would have been 1/2 mv squared. Okay, and the mass that I'm talking, if I added both masses up, this one wasn't moving, so we don't consider it. So it's 1/2 times m times 10 squared, right? So that's 100 divided by 2, so it's 50 joules was the kinetic energy initial. Okay, so if it's conserved after they move off together, they should be the same, right? Let's see if it is. So the kinetic energy final is going to be 1/2 of both the masses, right? Mass 1 plus mass 2, right? V squared. So 1/2 times 1 plus 2 is 3, and then V, we said it moves off with 3.33333, or let's just do 10 over 3 in this case. Squared. Okay, so if I go ahead and calculate that out, okay, I'm going to get 10 over 3, and then if I square that times 3 divided by 2, I'm going to get a kinetic energy final of about 16 points, let's just say 6-7 joules. So I have considerably less energy, kinetic energy afterwards. So you may say, well, that's like magic, like where to go? Like how does energy just disappear? And it goes to two places. Okay, that energy, notice we have a lot less, by the way. 16 versus 50. How much less did we have? Well, if I took the ratio of the final over the initial, that ratio is going to be 16.67 over 50. So I only kept about 33% of my energy. Okay, so where did the other 67% go? It went two places. It went to heat and it went to sound. Okay, so that's a hallmark of inelastic collisions. In fact, 33% is actually pretty high. A lot of times in inelastic collisions you'll get numbers almost like 0. Because remember, if I had two cars coming towards each other, they could have a lot of kinetic energy in the beginning and then they could just stop completely. They could go splat and there's no kinetic energy after, right? So this is normal for inelastic collisions to see very little of that energy retained, the kinetic energy. If we were doing elastic collisions, it's the complete opposite. You retain all of the energy, but inelastic, it's definitely not conserved, because two objects can come and hit each other and not even move off at all. So and again, the rest of that energy went off as heat and sound.